Hi, so in this video, we're going to talk about redox reactions, okay? Redox reactions are also known as oxidation reduction reactions, okay? So the main thing that we need to understand about redox reactions is, in these reactions, electrons are the ones that are always getting transferred from one species to another, okay? So consider you have a reaction, let's say A plus B gives us A plus, so that's an ion, a positively charged ion, plus B minus. So in this case, we can see that A from here actually lost an electron, okay? So it lost one electron. And because it lost an electron, it became a positively charged ion. Now B, on the other hand, it gained an electron. And because it gained an electron, it became a negatively charged ion, okay? So therefore, what happened out here is there was an electron that was transferred from A to B, okay? And when the electron was transferred from A to B, A became A plus and B became B minus, okay? So this is an example of a redox reaction or an oxidation reduction reaction. So let's go ahead and define what do we mean by oxidation and what do we mean by reduction, okay? So oxidation is defined as the loss of electrons. So if you go back to this equation out here, we can see that A lost electrons, therefore A is oxidized. Now reduction, on the other hand, is defined as the gain of electrons, okay? So if we go back to this equation out here, we can see that B gained electrons, therefore B was reduced, okay? So consider another reaction. So out here we can see that we have Mg plus Cu2 plus giving us Mg2 plus and Cu. Now if we look at this very carefully, we try to just understand what happened to each of the species. We can write that Mg changed into Mg2 plus. And because Mg went from a neutral species to a positively charged species, that means Mg should have lost electrons, okay? So lost electrons, okay? And because it lost electrons, what we're going to say is that Mg was oxidized. Now, if you look at the other species out here, Cu2 plus, let's try to track what happened to Cu2 plus. I'm going to write that out here. Cu2 plus became Cu. So it went from a positively charged species to a neutral species. So it must have gained electrons to quench those positive charges, okay? So we say it gained electrons, okay? Now, if you want to get technical out here and understand how many, well, for each charge, it should gain one electron to neutralize it, okay? So each positive charge means it gained one electron. Therefore, in total, copper 2 plus should have gained 2 electrons, okay? So since it gained electrons, copper 2 plus is reduced, okay? So now we had an oxidation taking place and a reduction taking place, okay? So this process from Mg to Mg2 plus is the oxidation. I'm going to write that like this, oxidation. And this process is the reduction. Okay, so again, this is a redox reaction. There's an oxidation taking place and a reduction taking place, and they're both taking place at the same time, okay? So now that we understand that, what we can do with every redox reaction is we can split them into two halves, okay? The oxidation half and the reduction half, okay? So the oxidation half reaction, you can write this as the number half, or you can write this as the word half, which is HALF. So the oxidation half reaction is going to be this half reaction. And the way you write it is you always want to make sure you represent the electrons that are actually gained or lost in the process. So in this case, since Mg is losing electrons, you will actually put the lost electrons on the product side, okay? So the oxidation half reaction is going to be Mg goes to Mg2 plus 2 electrons. Okay, now the reduction half reaction is going to be the Cu2 plus, which gains the electrons. So in the reduction half, the electrons that it gains is always going to be in the left hand side. Okay, and that gives you Cu. Now, very interestingly, if you actually add the oxidation half and the reduction half, you'll see that because these electrons are on the reactant side and these are on the product side, they'll actually cancel each other out. And if you add them up together, you should get, whatever you get out here is essentially the redox reaction we began with. Okay, so that's kind of a good way to check if you wrote the oxidation half and the reduction half correctly. Okay, so now that we understand this, the other piece that we want to talk about is anytime an oxidation takes place, a reduction will also take place. And when the oxidation and reduction takes place, we have to identify what's the oxidizing agent and what is the reducing agent. Okay, so in this case, when the magnesium gets oxidized to magnesium 2 plus, someone has to help the magnesium get oxidized. And in this case, it is the copper 2 plus. Okay, and the reason for that is because when magnesium goes to magnesium 2 plus, and if you can actually look at the oxidation half reaction very carefully, we can see it produces 2 electrons. So those 2 electrons have to be accepted by someone else who's looking for 2 electrons. And that's going to be the copper 2 plus. Okay, so therefore the copper 2 plus happens to be the the oxidizing agent. Okay, because it's helping the magnesium oxidize to magnesium 2 plus. Okay, so the copper 2 plus is I keep writing reducing, apologies for that, is my oxidizing agent. Conversely, notice carefully what happens to the copper 2 plus. The copper 2 plus becomes copper, right? Meaning it gained electrons. Okay, so in order for the copper 2 plus to gain electrons, it needed someone to reduce it. Okay, so therefore the magnesium is going to be the reducing agent. So a quick and easy way to kind of figure out which one is the oxidizing agent and which is the reducing agent, take a look at what happens to the species. So the species that gets oxidized is always the reducing agent. Okay, so the magnesium gets oxidized, it's the reducing agent. Okay, and the species that gets reduced is always the oxidizing agent. And the last thing out here is the reducing agent and the oxidizing agent are always going to be one of the reactants. Okay, so if you have 2 reactants out here, one of them has got to be the reducing, one of them has got to be the oxidizing. It's never going to be the product. Okay, I hope that makes sense.